I'm Nils Røkke. I'm Executive Vice President of Sustainability in SINTEF. SINTEF is a research institution here in Trondheim and in Oslo. And well, we've got 11 sites around the country, but these are the two major hubs. We're working on the technology for a better society. Nowadays, we work on all issues which are related to how we can transform our economy to become into a sustainable situation, which is not the case at present, unfortunately. We see new technologies, or you could say old technologies, being brought up as the new solutions to this, like batteries. I mean, it's been around for a lot longer time, but it's something which is urgently needed for mobility, and it's also very important for the energy system to store energy. The other one I see also very, very strongly now is hydrogen, and how hydrogen can be part of the transformation of the society in many of the same areas where I mentioned batteries. And then, of course, you got, from Norwegian perspective, also how do you deal with the residual emissions from industry and so forth, where CCS has, so carbon dioxide capture and storage has become more and more important, also to be towards the net zero society by 2050. We need to have some measures. I mean, we're a small nation, but we are a major energy exporter. And this is the transitional imperative, how we're going to transfer to become net zero, also in Norway, and from the products we are exporting. Now, this is what these politicians are struggling with, of course, how to maintain this society with the jobs and the sustainable activities. We know that activities we have today are not sustainable, and what is the path towards sustainability? One thing which concerns me a lot these days is that we don't think about technological solutions. We need to think about solutions which works for people. We need to have a society which works for people, an industry which works for people. The transition needs to work for people. They need to have jobs, need to be able to sustain their lives, you know. And if people just think about this is going to take away a lot of the goods and activities I have today, it's not going to be a popular thing. But if you can show that there are jobs in this, I mean green jobs, and I think that is so important that we can show how we are going to do this transition in a way which works for me and you. That we can still have jobs, that we can do this in a sustainable way, and that we get the acceptance in the population that this is needed. And many people are talking about we need to have brave politicians, for instance, you know. We also need to change the people's opinion to have brave politicians which can take these steps. Time is over for, you know, linear extrapolations. We need to take the bets on something. And I think from the Norwegian perspective, we have our natural resources, we have a strong educated population. So we have good possibilities to take a role in this green transition towards a net zero and a climate neutral society by 2050. There is so much activities now in the battery area, and many companies want to be there. The hydrogen area, I mean, the value of the hydrogen companies at the stock exchange in Oslo is just booming. But these are just two examples. We need to have the whole portfolio of solutions, and they need to be they need to work for you and me. That's very important. Trondheim, which is a research and university city, can play a role in this, because we also have a lot of research centers which are focused on these technological issues and solutions, but also research centers which are looking into how is this going to be progressed in the future? What are the societal, what are the economical impacts and so forth, which can provide guidance to the politicians and stakeholders and decision makers. We need to have a holistic view on this. We cannot solve one crisis side by side. They need to be integrated in a holistic view. And that's where I think, you know, what is the most important part for us? Well, it's actually the planet, huh? So all these solutions we're trying to impose now to get to a sustainable solution, they need to be truly sustainable. I think Norway has a big possibility to excel in areas where we already know a lot of stuff. I mean, we're good in the marine environment. Shipping, for instance, green shipping is going to be very important. What stakes can we take there, and what technologies can we deploy to have zero emission ships, for instance? And then back to the hydrogen, CCS, or everything which is related to clean power. There we have a large opportunity as well. I mean, this is what the industry is based on in Norway. And of course, the raw materials which we have, which also fits into the batteries. We have resources which can go into manufacturing of batteries. We have the resources from oil and gas. We have everything which is, marine. We have fish farming and so forth. To do this in a sustainable way, I think we have a very good starting point.
My name is Annemie Wijkmans. I am a professor in architecture and planning at NTNU. And I am also the head of NTNU Smart Sustainable Cities, initiative that we created about 10 years ago across all of the faculties. So it's a way for all disciplines at NTNU to work together to create climate neutral and socially innovative cities. Smart sustainable cities, I think it's more an intention than an actual check the box kind of exercise. So the ultimate goal, of course, is sustainability. So a city that really is able to fulfill all the sustainable development goals. That is so massive a task that it's really difficult, of course, to, it's not a yes or no question either. It's a process on the way there. Smart, as in digitally enabled, is really just a way of getting there. But by combining smart and sustainable, we wanted to show that sustainable cities had been there for a long time. Smart cities had been coined by digital companies, usually without having any architects or planners involved. So we really just wanted to take smart back as architects and planners and show that, look, we can try to create sustainable cities, we can try to create better conditions against poverty, towards social innovation, etc., using the best that digitalization has to offer in terms of services, data, any kind of infrastructure, but only using it, of course, when it is an actual benefit. And combining it with a lot of different other methods and processes. We see now that with the start of Horizon Europe, the new European Research and Innovation Programme, more and more emphasis is put on innovation, societal innovation, and more on cross-disciplinary, cross-cultural cooperation in order to generate these ideas that are going to get us to a climate neutral Europe, and ideas often that don't really exist yet, or that might have existed but that never have been implemented on a larger scale before. And we see that need, that European need, fits really well with the way we've been working. It's kind of a merger of technology and science, and then art and culture and creative sectors, media, all together to create these new ideas. And we've never really known what to call it. So now we started to call it societal innovation, because we try to put together different disciplines, also citizens, different organizations, NGOs, to try to create solutions together. We as an initiative can't claim to be experts on absolutely all the sustainable development goals. So I think for us, we decided to make a combination then of sustainable goal, the SDG 11, obviously for cities, and then 17 for cooperation, and to really explore how we could create new or better types of cooperation between also different groups of people in order to reach these goals in a better way. We are doing this, for example, here in Trondheim in Sluppen, and then at Brattøra. And at Brattøra, of course, you also have the fjord, so it extends into then maybe electric ships, and how this then again can be connected to the building mass, and So you get very interesting questions there. But then with Ålesund, for example, we work on digital twin. They already had the digital twin. We did not develop that, but we are then looking into how it could be extended, you know, what more you could do with it. So, or if you do have a digital twin, let's say like a virtual 3D model of the city, you can feed loads of new types of data into it, so you can get a good visualization. For example, what happens if a school changes its opening hours? How does that affect traffic? Those types of questions. How can you then link geographical information, so GIS data, for example, to this in order to make the models even more accurate? We are looking into visualization, so how you can make that kind of data much more visual, so more people can understand it. You know, almost no one is going to read a report of 200 pages with lots of numbers, or only those that are particularly interested in it. But if you can make good visuals that are an accurate representation, then you can get more people involved in the discussion. So there is this amazing opportunity now to merge science, technology with art, culture and creative sectors, to do this in cooperation between public and private sectors, with citizen organizations, with media, with academia. You know, this setting is there and we can help define what it's going to become. The challenge is going to be that it needs to be very concrete, it needs to be local, because, you know, big words and big ideas are not going to save, you know, the world. So we need to both be able to create that framework, but also help create very local good solutions and showcase what can be done. So we need people both that can do that local work, and we need people that will want to more have this kind of policy interaction, for example, towards Norwegian and European Commission.
My name is Nicola Paltrinieri. I am an associate professor at the Norwegian University of Science and Technology, NTNU, here in Trondheim. I'm currently part of the board of the NTNU Team Hydrogen, but I've been elected as the next leader since the 1st of July this summer. The NTNU Team Hydrogen is a pretty exciting group in NTNU, transversal through the different faculties. Of course, focusing on hydrogen technologies, on the hydrogen value chain, for instance, and many other aspects that are focusing on the related research, development, enabling of this new sector, industrial sector. Hydrogen is a way to store energy. And it's very valuable for what concerns renewable energy. Why? Because renewable energy is not a steady source of energy. Wind, sun, and water and hydro energy, they are not providing a steady source of energy, because they might have peaks, and of course the demand might not match, most of the time does not match these peaks. Okay, so you need to find a way to store this energy. A way to store energy is also on a chemical point of view to produce hydrogen in that sense. So with electrolysis you basically produce hydrogen from water. Hydrogen then can be burned, can be used as a fuel, and it has in the moment you use it as a fuel, the byproduct, the main product for you is energy, of course. The byproduct in that sense would be vapor, water. Here in Norway, there is a very good focus on the maritime use of hydrogen. There is a big hype now in Norway for what concerns hydrogen, and I think that these opportunities should be taken, and actually they should be seen as opportunities. And I think also the role of the NTNU team hydrogen is very important in that sense, because as I said, there is a lot of knowledge there, but we need research still. But also we need the communication, because we need acceptance by the public, by people, by the citizens, but also by investors. Okay, which means that something like the NTNU team hydrogen can work on this, can provide education for the students that will grow up as future engineers or experts in hydrogen in that sense. Another thing that I think is very important for Norway is the fact that there is the possibility to have an energy mix. Because, you know, from the investment point of view, you never want to invest on only one thing. So you better have an energy mix. So you have to keep in mind green hydrogen. You have to use what you have already available for the blue hydrogen. The green hydrogen should come from, for example, wind, water and sun. So you should take into account the batteries as well. Batteries are very important as energy storage, but also in order to be used for transport, electric transport or hydrogen transport, because also when you have a hydrogen car or another way of transport powered by hydrogen, you need the battery. So diversification is also another important word in that sense. With this next hydrogen revolution, this next hydrogen shift, energy shift, we really need to be prepared. Industry needs to be prepared. Society needs to be prepared. Preparation is the key in that sense. And we need to use the knowledge that we already have, because we have already a lot of knowledge. We need to connect the points in order not to just to think of boxes separated of disciplines, but talk to each other across the disciplines. That is very important in order to put really the basis, a fertile ground for this energy revolution. A group like the NTNU Team Hydrogen, with this interdisciplinary soul, is very important in that sense. And I believe that such a group would help with these challenging goals, and also will help in order to form the society of tomorrow, and at the same time communicating to the society the results that we are getting, the potential that there is in this energy sector. So I'm strongly advertising the NTNU hydrogen with this, and I believe that we will be able to do great things.
Hey, I'm Jo Utus. I'm the CEO of Creanano, a semiconductor company based out of Trondheim, where we are bringing to market nanotechnology for UVC-based disinfection. Our UVC-based LED combines both graphene and our nanowires. Graphene is a novel material. It's a two-dimensional material. It has numerous application areas, but most notably for Creanano, it is a superconductive material and it's super strong. Last night I was looking at some favorite, YouTube movies from cyclists, and I even saw a manufacturer creating a bike based on graphene. And their pitch was, well, it's lighter, right? It's lighter and stronger, exactly the same properties as we're looking for. And we see this happens, everywhere, right? Graphene is replacing existing materials due to its strength, its conductivity, or the weight. Creonano's patented technology is currently being applied on UVC LEDs, but it has an extremely wide application area, much beyond the light-emitting diode, which is the UVC LED. Within optoelectronics alone, the markets that are adjacent to UVC LEDs or other LEDs is massive. And we will see a shift towards miniaturization in semiconductors. It's what the entire industry is about. And seeing the opportunity of this technology is fundamental for the growth of semiconductors, but also the opportunity for Creonano. Where existing solutions today fall short on manufacturing yields, meaning the cost is high, we increase in scaling for the manufacturing, but it also allows us to increase the output power and the characteristics of the UVC LED, which is important when we go to market and we compete with the existing solutions today. We have a small manufacturing setup here in Trondheim, but we are a fabless company where we source the manufacturing partners worldwide. And we use existing semiconductor foundry equipment. And that is important because it allows us to move into volume manufacturing with our products. So the equipment is to some extent expensive, but for our supply chain partners and foundries worldwide, the equipment is available and installed already in the foundries, in the clean rooms. For Creonano as a company to design and build and manufacture UVC LEDs for a world that needs disinfection, obviously we're not healing the world, but we're really helping humanity with disinfection because it's more cost efficient, it's lower energy consumption, so the CO2 footprint will be really dramatically reduced, but also we are replacing products that are toxic by nature, right? Disinfectants we see, everywhere around are toxic. Also, the mercury-based lamps that we see in the UVC products today are toxic. So we're not only solving a fundamental functional problem, but it's a health issue that we're also solving and addressing with our products. With Creonano's technology, I think the future of sustainable cities and building healthier cities is absolutely instrumental. We see requests from strategic customers who are looking to build products and solutions that don't exist today. How do you create trust in a population post-pandemic, where you have interfaces to touch, right, buttons to push, literally, create trust through disinfection? I think that's an area where Creonano can play a piece, right, with system integrators, with public, health authorities, through the regulatory bodies that we see will emerge and regulate this market, which is required and really, really good. In the future, you will see disinfection solutions based on UVC LEDs that are more integrated and smaller, found in the household or for commercial use, that are not available today because you can't design these products today with the current solutions. Setting up the company in Norway obviously makes a lot of sense since we're based off technology from NTNU, but the proximity to SINTEF and NTNU is instrumental for us. But when we also hire people, we see that when we find researchers, engineers and industry experts from the US, UK, Japan, Germany, India, they are extremely eager to come work for Creonano, not only because of the technology, but also because we're in Norway. The interest has really increased during 2020, probably because of the pandemic that we see, right, and the way that the Norwegian government is dealing with the pandemic and the way of life. Following the Nordic model leadership, it looks like a fairy tale. Well, this is how we succeed, right? And there are numerous examples in town and other locations in Norway as well of semiconductor companies that are really grown and become really, really successful. So we have demonstrated our ability to be extremely productive, forward-leaning, innovative out of Norway. So I would say there's a huge advantage of being in Norway, where we can grow, have a wonderful work-life balance, at times, as well as access to competency. Crayon Nano's biggest challenge right now is there's an unlimited appetite for UVC LEDs in the market. There's not enough supply in the world. So it is important for us to go to market fast and really to accelerate the go-to-market plan. And that's really what we're working on, to move into foundries that are able to and willing to move into volume production with the company. For us to be able to go to market and support the customers that are looking to build disinfection solutions today, tomorrow, and for the future. We see a tremendous interest in the company. And these are from other companies and other people who have been in the industry in semiconductors for quite some time. And they're now starting up new companies, and they're extremely willing to share. And I think that the ecosystem in Trondheim, in Norway, is really happy to support us, right? I feel there's a mix of cheerleaders as well as mentors and coaches that are extremely willing to give their time, put effort in supporting the company. And I'm really grateful and really happy to see this. And I would really like to encourage people to return favors and support where they can, because that's really what the ecosystem needs.
Every day, the world needs more energy to process and store information. Society is pushing the fundamental limits set by known physics. It is more important than ever to expand our understanding of the physical world and develop basic science to open new doors. At QSpin, we're training a new generation of scientists to discover new phenomena involving the quantum spin and exotic quantum properties. Planets orbit around the sun. The electron behaves in a similar way. It rotates around its own axis. This spin has great potential. Our objective is to develop the basic science to use quantum objects, such as the electron spin, as information carriers in radically different ways. Using theory and experiments, we are discovering fundamental properties of new materials to control quantum variables, so that one day, we can transport and store information in entirely new manners. And ultimately, these concepts will trigger a revolution in low-power information and communication technologies in an energy-efficient society.
My name is Arne Brattås. I'm the director of QSpin. Quantum Spintronics is important on many levels. It's important from a fundamental point of view because we get to understand more of the intriguing phenomena that goes on in new kinds of materials that we could not see before. But it's also important from a technological point of view because devices are getting smaller and smaller and they use more and more energy. We are now making use of a tremendous amount of energy for basically do nothing, even when the computers are standing still. So in order to solve some of these challenges, we need new ways, new quantum mechanical ways, and spin is one possibility that's exciting. In technology, there can be many uses. There can be memory devices like hard drives, in computers or in watches like one I have, or cell phones. But it can also be sensors detecting different kinds of gases in air, for instance, that can be pollution. It can be optical devices, so it can be television screens. It can be communication for cell phones or for internet. It can be in medicine. It can be small devices that you can implant into the body to detect various diseases or try to correct if you're ill. So it's very broad. The majority of the funding is from the Research Council of Norway, But then also the Norwegian University of Science and Technology, they also fund part of the center, so it's twofold. But we also have other grants from the European Union that are in addition to the big funding we have from the Research Council in Norway. The timeline is very long. It depends now on what you consider the goal. If you consider the goal to be some technological device, then I think the timeline is 20 to 30 years. So that's beyond the lifetime of our center. Our timeline is more to reveal new, interesting and exotic properties. So that's typically, let's say, 5 years if you would like to do something experimentally based on the ideas we have now. But as we go along this path, we get more opportunities and more things open up for us. So the goal might be changing to something radically new. And that's what we continuously are doing.
My name is Sol Jacobsen. I'm a researcher at QSpin and I work in superconducting spintronics. The goal of superconducting spintronics is under the broad umbrella of the goals of spintronics, which is to reduce how much heat is lost in computation. At the moment, in electronic computation, we lose half of the energy to heat. Superconductors can use this property where they can send information entirely without heat loss. And it's one of the things that we in Spintronics look at to try to solve this problem. My specific research is trying to challenge the way that these spintronic components have been built conventionally, where they've been layered, superconductor, normal metal, maybe a magnet, insulator, and so on. I'm looking at maybe curving them or separating components and having photon-mediated information transfer between them. That's my specific goal. One of the challenges is how to make the field attractive to those high achievers, because choosing the direction for the best applications is a very, very difficult question, and we need the best brains on the job.
I think a lot of people coming to the lab expect it to be like shiny instruments that look all professional, but instead you see lots of bits of stainless steel and cables and aluminium foil and crocodile clips. My name is Justin Wells. I'm Professor of Physics at NTNU, and I'm the main responsible for the experimental activities of QSpin. The main method that we use is based on photoelectron spectroscopy, which is essentially a refinement of Einstein's photoelectric effect, which he got the Nobel Prize for in 1921, in which when high-energy photons hit a sample surface, then there's a possibility that this results in electrons being emitted. So in Einstein's day, this was an interesting phenomena to try to understand, but more recently people have realized that if you analyze the electrons which are emitted, they contain a lot of information about the sample. So the main method that we use is a refinement of this technique, that we shine light on a sample of either ultraviolet or X-ray energies, and we collect the electrons which come off, and we analyze their angular distribution, their momentum, their energy, and now also their spin. The spin detector which we have recently installed is at least 1 million times more efficient than what was available 10 years ago. So measurements that we can now do in a few minutes previously would have not been possible. They would have taken years of collection time. I think a lot of people misunderstand the time involvement between proposing a new concept and actually demonstrating the reality of it. But this is not an instant process. You can't sit in your office one day and predict a new quantum state of matter, and then a week later we have it in the lab available for you to measure. Our business is to understand the fundamental physics, both from theory and experimental verification, such that new knowledge exists in society which will be of the benefit to the society in the future.
I'm Ingrid Dina, and I'm the CEO of Norwegian Mycelium. I have a commercial background, but I always had a passion for technology, and especially technology that makes a difference and can solve big problems. I come from 15 years in Google, where I've been working both nationally and internationally. So I've been based in Norway, but also many years abroad.
Yeah, and I'm David. I'm the research lead for Norwegian Mycelium. I am a research scientist and fungal expert by training.
So David and I, we met through the startup world, the connections there in August last year, and we officially established NOMI in November. So we're still a pretty fresh and new company. And both of us could really continue business as usual. We could have continued with our careers and we could do what we're best at. But we're both really aware of the big sustainability challenges that the world is facing right now. And business as usual is not really any option anymore. So we both kind of share this passion for making a difference. And we're both very interested in being able to make the world a little bit more sustainable and resilient.
Most people know about fungi through, say, a mushroom, right? Most of the life history of fungi is below ground and it's invisible. So consider, what if everything we knew about an apple tree was from studying just the apple? And it's the same with fungi. And we're just now kind of remembering, rather than discovering, how fungi work in nature to be able to tap into those stories in how we can live more sustainably. The other area that we're being innovative is in this thinking of circularity, of thinking more on how fungi have used its life histories and how we can use those life histories to develop new and innovative products. So it's that thinking from going from linear to circular in how we utilize our resources.
So we're trying to solve two big problems. The one is the extensive use of EPS foam plastic and mineral wool, and the other one is the unsustainable production of food and feeds. So let's start with the plastics and consider this. By 2050, the ocean is likely to have more plastics than fish, which is terrible. The production of plastic, it comes with such huge hidden costs to the society and the environment. And why do we keep on increasing the use of plastics in the world? And the answer to that is simple. There hasn't really been an alternative that can compete on both price and performance. So what if we could create that alternative and grow it instead of actually make it and produce it? It can come from natural resources. It can be 100% compostable, and it doesn't require any arable land. And we could also do that with a fraction of the carbon footprint. And at the same time, it will have the same qualities when it comes to performance, and we'll be able to keep the same cost level. Wouldn't that be good? And that's something we'll be working on using mycelium.
You know, when we started the project, we analyzed 12 use cases, everything from biodegradable car parts to mycelium nanofilms to be used in aeronautics industry and sensors. And we really arrived at 3 that we think are going to be the ones that are going to create real impact, focused on everyday products and producing them at scale. The first one utilizes what is akin to a vertical farming technology to be able to create new materials that can replace EPS foam plastics and rock wool for building applications. So things like thermal properties or isolating for sound. So we're working with actors within the building industry, in the green building industry, to develop a new type of materials that are fully biodegradable. Another area that we're working that utilizes the very similar technologies is in the production of new foods. So this is a very hot area in thinking about how we're going to shift away from meat diets, from very heavy meat diets, into more plant-based. And this is a great space to be into. But with mycelium, we can actually go beyond, for example, what Beyond Burger can do, because we can make a whole food cut product. So instead of being something that's pressed together using chemicals and a long ingredients list, we can create a clean label by making mycelium that really gets at the heart of what many meat eaters want, which is that whole cut, craveable, prime cut experience of eating a whole product, a whole food product. And I think that's a really exciting space to be in. But we have to do it in a way that's delicious if we want consumers to eat it. So with our product, we're able to use fermentation technology to be able to make a product that is every bit as craveable and even more so than a piece of meat. And if we're going to shift diets, if we're going to actually accelerate the green shift to more sustainable eating, we need to target those that need to shift their diets, the meat eaters of the world, by making an amazing product that people want to consume. So the other area that we're working in is looking at developing a proprietary technology for the development of new sustainable proteins for the feed industry, particularly for fish feed. So right now we're using wild-caught fish. We're using arable land in the other side of the planet, burning down rainforests, to be able to make the proteins needed to be able to feed fish here in Norway and abroad. And using our technology, we can create these proteins using mycelium and partnering them with other producers of large feedstocks from waste industries of, for example, forestry or from agriculture, to be able to make a more sustainable protein right here in Norway, using no arable land at a fraction of the environmental footprint. And we think this is going to be the future.
So before we started, we knew that the technology works. So what we've been focusing our time on is getting validation from the market. So we've been speaking to thought leaders within the industries we want to enter. We talk to investors, we talk to clusters, networks, and partners. Partnerships are going to be key to us. So we talk to both industrial partners and potential commercial partners, because we really need those in order to do this at scale and have create real impact. One of the other challenges we'll be having is attracting enough talent to Norway and to, of course, to our company. So how do we get the brilliant minds with the right competence to come and work for us? And I'm assuming that a lot of the other deep tech companies here today have the same challenge. So I'm hoping this can be a topic for discussion further.
So we know we're just scratching the surface. We think we're in an exciting area, and we're looking forward to taking this further. If anyone wants to get in touch to see how we might be able to work together and partner, then we look forward to hearing from you.
My name is Vegard Vollan, and I am the CEO of Technoport. I have been working about 30 years in the chips and semiconductor business since I was educated at NTNU from microelectronics and computer architecture. I started at Nordic Semiconductor, and then I spent over 20 years at what was Atmel. And 5 years ago, we started a new startup in Trondheim, which is Maivo. That company we have now been running for 5 years, and we are currently, exactly in these days, merging with a UK company called Technoport. So we have been closely working with Technoport as a partnering company, so Maivo and Technoport as collaborators during actually all these 5 years. And there are very strong and solid synergies on both sides. For the first, we are in the same specific product area, aiming for the same unique features, unique offerings to the similar customer base. We are also very complementary in the sense that Technoport traditionally has had a very strong skill set in the system expertise and in the touch sensor side, whereas we in Maivo has been experts on the chip and the sensor chip architecture. Yeah, so the offering we have within Technoport and Technoport Maivo has been aimed towards a niche of touchscreen applications. When we started in 2016, most touchscreens were developed for the mobile market. So they were developed for cell phones and tablets, etc. The industrial market and, for instance, medical applications, automotive applications had higher requirements which were not fulfilled by those offerings. Those were features for robustness and lifetime of these products, but it was also features related to the application itself. And what we have developed, which really is unique, is that our touch sensing is much more sensitive, to put it that way. So for a standard touchscreen, you would only need a certain sensitivity to be able to measure capacitively the human finger. But with a much higher sensitivity, we are able to do that same measurement outside the screen. And that offers a range of additional features and applications. For instance, you have touchless user interfaces, which obviously is a use case with a lot of positive measures, particularly in the situation we have now with COVID and virus, bacteria transmission and transfer between multi-user and public touchscreen users. A touchless user interface would allow for that not to happen. So with the 3D sensing for the automotive and car market, the key rationale is to enhance driver safety and eliminate driver distraction. And driver distraction is only in Europe causing about 20,000 seriously injured people and about 4,000 people dying in accidents from driver distraction. By having 3D sensing, you can enlarge icons as you approach, such that you are easier hitting your destination as an icon. And you can also, in the application, add curvature and finger guides to the system, such that if you have finger guides, for instance, on the edge of the screen, you can keep your eyes on the road, and you can use these sliders to change temperature, volume control, etc. And the good thing is that we are no more expensive than what's there today, because the touchscreen controller typically sits on the flex tail of the sensor. This is actually a sensor, but it's transparent, obviously, because you put the LCD underneath. And the sensor then is connected to the sensor chip, and the chip then is actually what is performing the sensing. And the big thing about us and Touchnetics and our offering is that for touch you need the touch controller anyway. And we just replace what's the current touch controller and offer 3D sensing at the same time. So no additional sensor electronics and no additional cost for the user. So the main challenge I would say we have had, and which is also common in our industry, is that developing chips and hardware is so capital intensive. So it requires a lot of capital. It actually also takes quite a long time before you get to the stage where you can engage with customers and win programs and start manufacturing and attaining the income from what you do. So the runway you need before you get income is quite long. That has obviously been a challenge for us as well. Yeah, so I think in many regards we are fortunate because we have been in this industry for so long. So we do have a lot of network and capabilities ourselves, and I do recommend people going in their niches or markets, team up and partner with people in that regard to leverage on people's relationships and networks. Obviously for us, we are in Tech Trondheim, the Technology hovedstaden, which is great, but on the other hand, we still plan to recruit people in the coming time, and there is a lot of competition to get people, which is good on one hand. On the other hand, I think we also would want more and need more people in our industry in Trondheim.